Welcome, 10th grade. My plan was to have you complete up to self-test 3 by Friday, and then Monday morning you would be able to do the self-test. Some of you had questions on Friday when I text you, and so I will try to answer some of those questions. And if you had other questions, feel free to call me, but maybe this will get you started. So I'll just start out with the question that I had was on page 34 and 3.5. So if you turn in your books to 34, 3.5 says this way: the sum of 3 consecutive integral numbers is 117. Find the numbers. Okay, you have 3 numbers and they are consecutive, so that means they're like 1, 2, 3. So the way you set the problem up is you'll use x for one number. I hope you can see this. Maybe I'm almost off the screen. X, and then x plus 1 would be the next number, and x plus 2 would be the third number. And the total of those numbers will equal 117. The way I would combine all my x's to start with, so that makes me 3x, and then I add my 1 and my 2, which makes me 3. Now the next step of the problem is you'll need to isolate the x, or get it by itself. So take your 3 over to this side, and when you cross the equal sign, you know how you have to do the opposite. So to get the 3, you have to subtract it from the 117, which will make you 114. Now the next thing is you have 3x, or 3 times a variable. Divide your 3, use your 3, divide it in there. That brings the x by itself. What you do on this side, you have to do on this side. So now divide 3 into 114, and that makes you 38. X equals 38. So now if you back up to the top, that means your first number is 38. The next one is 38 plus 1 is 39. And the next one is 38 plus 2 is 40. So your answers for 3 consecutive numbers, if you add them up, is 38, 39, 40, and that should equal 117. I didn't check it, but I think that's correct. It worked out correctly anyhow. Now the next question I had was 3.7, and it says this way: one number is 800 less than 3 times the other, and their sum is 1200. Find the numbers. We're still on page 34. I used x for one number, and the other one is 3 times that number. Subtract 800. And so if you can set the problem up, that's the key point here. 1200 if you add the 2 together. Okay, now don't miss that. 3 times. So if you go 3 times in an x, that means you have 4x. Now again, you're subtracting 800 here, so to eliminate that, I had to bring the 800 over here to this side, which, like I told you, when you bring it across the equal sign, if you remember, you will need to do the opposite. There's more than one way of doing this. I don't know if you remember last year, to eliminate this 800 on this side, we would plus it, and that would eliminate it, and then you'd come over here and you'd bring the plus over here. That works as well. But you have, on this side, the 800 is positive. So your 800 plus 1200 is going to bring you 2000. If you add those up. Now, you have the 4x here, so you need to isolate the x. You know how to do that, 4 into 4. And of course, you have to do the same thing, 4 into 2000. You can do that in your head, brings you to 500. Now, x equals 500. So your first answer for x is 500. The second one is 3 times 500, which you can do that in your head, it's 1500. Subtract 800. So if you subtract 8 from 15, it makes you 700. And if you go add those two numbers together, 500 and 700, that will equal your total of 1200. Now, the next question that I had was 3.15. And you will need to turn over just another page here. That should be page 36. At the top of page 36, it says for 3.15, a man has 2 more nickels than dimes. He has $1.15 in all. How many coins of each kind has he? Okay, you think through what you're doing. You have $1.15 total. And we're going to let X represent dimes. And then this one, he has 2 more nickels than dimes. So I put X plus 2. So I put the 10 here. That's because a dime is 10 cents. So you got 10 cents times X, times X. And then you have 5 cents times X plus 2. Now, you see the X plus 2 is in parentheses, so you will need to solve that first. If you recall, when you have this, you can combine these two by multiplying 5x, which I did here, and then you have to multiply 5 times 2, which is 10. Okay, you still have the 10x up here. I didn't move it down. So here you have 5x plus 10 and 10x. So you combine those two, you have 15x. But before we get too far here, you see you got the positive 10 here, or plus 10. I need to eliminate it, so I move it over on this side, subtract it from the 115, and I have 105. Now, I have my 15x here. I eliminate the x, or isolate the x, by dividing 15. What I did here, I did on the other side. So I come down to x equals 7. So you can put 7 back up here. You had 7 dimes. And then you had 7 plus 2 makes 9. So your answer is 7 dimes in 9 nickels. Now you can check this one. I didn't check it. But you can go 5 times 9 and 7 times 10. And that together should equal $1.15. Now if you notice the decimal point, I left the decimal point out because it was 2 places here, 2 places here, and it was been 2 places in the $1.15. You have to be careful depending on how it comes out. You may have to put the decimal point in, but where there was 2 places in each figure, you could eliminate it and pay no attention to it and work out the problem. Okay, the next problem that I had was on the same page, on page 36, was 3.19. So I'll move over to the other side of the board and do that one. Okay, I'm not sure if the lighting is correct here. Let me move it just a little bit more. Okay, 3.19, and I'll read the problem. 30 adults and children paid $12.25 for a trip. If the adults paid 50 cents each and the children paid 25 cents, how many adults and children went on the trip? Okay, here again, you let X represent the children, and they paid 25 cents. You know that there were 30 total. So however many children there were, you will need to subtract that from the adults. And you know the adults paid 50 cents. So the key point is here is setting up the problem correctly to figure out the value of X. The $12.25 again was how much they paid total. And you know 30 was their total number. So I dropped the decimal. As you see again, I let the decimal go. And I had, for X, the children paid 25 cents. So it's 25X. and 50 was the amount adults paid. And I put the 30 minus X in parentheses because it was 30 people total minus the children, and X is representing children. So here I solved this in parentheses. You had to multiply 30 times 50, which made you 1,500, and then 50 times X. Now this is negative X. Take note of that. So when I brought this down here, I had 1,500 negative 50X. Hope I'm not going too fast here. And then I still brought my children just positive 25X. All right, you can combine these two, the 50 negative and the 25 positive, which makes you negative 25X. Okay, we come into a negative because if you subtract 50 from 25, you have negative 25X. Now the 1,500, it's positive here. You will need to subtract it from the 1,225. So if you subtract 1,500 from 1,225, you again get a negative answer, which is a negative 275. Now, bring over here and isolate the negative 25X. So that means you divide 25 into 25, brings you down to X. Divide 25 into 275, and if you recall that dividing two negative numbers equals a positive number. So you're dividing negative 25 into negative 275, and that brings you to 11. It's a positive number now because you have divided two negative numbers. X equals 11. So that's not hard to figure. There were 11 children, and so you'll put 11 here again. 11 subtract 30 makes 19. So your answer, if you can see here, is 11 children, 19 adults. Yeah, that section is working with these type of problems. Now the next section on page 36, or the bottom of 36 on over 37, 38, over on to 39 is a whole different style. You are working with distance, rate, and time. And I had a couple questions there. I will only do one more problem here, 3.20 on page 39. So if you turn your book over to page 39, I will do the first one there, and then that's all I will do for today's class. If you have any more questions up to the self-test, you call me, and we will still try to do self-test Monday. Today. 3.20, I worked it out here, but let me explain it. I'll read it to you. At 2 p.m., two cars started toward each other from towns 240 kilometers apart. Two towns, two cars started toward each other. Okay, get the picture. At the rate of if the rate of one car is 10 kilometers per hour faster than the other, how fast does each car go if they meet at 5 p.m.? Okay, there's two cars coming. They started at 2 o'clock, and at 5 o'clock they met. So that's 3 hours. And it was 240 kilometers apart. So I put it up here. The one was going 10 miles faster. The slow car was just going to represent for X. The fast car was X plus 10. It says he was going 10 kilometers an hour faster. So you have the rate times time equals distance. RT equals D. And the time, I put it right over here, was 3 hours. From 2 o'clock to 5 o'clock was 3 hours. So you have to think through these problems to see which way to set them up. Sometimes you won't always have the distance. Sometimes you'll find the distance. On this problem, I put it out like this. You have The distance is 240 kilometers. So put 240 over here. The time is 3 hours. You know that the slow car went 3 times x. You know that the fast car went 3 hours as well, 3 times x, but he went 10 miles a kilometer faster an hour. So I put 3x plus 10. I put that in parentheses because you'll have to solve 3 times 10. So if you solve that out, you have 3 times 10 is 30. And then you have the 3x here plus the 3x here. So that makes you a total of 6x. You have plus 30. You know what to do on this side? Subtract it. So that brings you down to 30 from 240, makes you 210. You have the 6x, you bring it down, isolate the x, divide 6 into 6, divide 6 into 210, makes x equals 35. Now, you know that the first car, the x value is 35, and you're driving kilometers per hour. So, the slow car was going 35, and it's not hard to figure out the other one. He was going 10 miles an hour faster, so he was going 45 kilometers per hour. You can check them out if you want to go 3 times 45, 3 times 35. You check the answer and see if it comes up to 240. So, you have fun doing the rest of them. I will help you more if you get stuck on some of the others. You can look at your examples. Setting up the problem will be the key. Thank you.